Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engines course, and this is the chapter 5. The chapter 5 is dedicated to the cylinder head and valves. And we are going to check the different type of heads used in marine inboard engines, in marine applications, and the characteristics of each type of head. This video is accomplished with a couple of jobs that I did in different boats, and we are going to share that information in this video. I hope you enjoy the video. The head is the element that is damaged easily if the engine have a thermal or thermical problems or problems with temperature. When you have a problem of temperature, your engine was overheating, 100% sure that you have a problems on the head. Probably the head is bended, or probably the head gasket is blown, the head gasket is damaged, and you need to replace the head gasket and you need to repair the head. When you have problems of temperatures, at the end of the day, you have problems on the head, and you need to remove the head and replace the head gasket and repair the head, or replace the head in some cases. The head is critical. The head is the element located on top. The head is the element located on top, and this is the block. This is the block of the engine. And the head is located here. This is the head. This is the head. The head is separated from the block with the head gasket. The head gasket is the element that seals properly in between the head and the block. In between the head and the block is created the combustion chamber, that small volume created in between the head and the piston is the combustion chamber. If the head is properly torqued, if the head is in good condition, if the head gasket is the appropriate head gasket, if the piston rings are the appropriate piston rings, the seal in the combustion chamber is good and the compression on the engine is perfect. If you have a problem of lost compression, it's because you have a leak probably on the head gasket, because the head gasket was long and you have a leak on the head gasket, or probably you have a air coming out through the rings because the rings are broken or the rings are wear, or you have a problem with the rings and the air goes in between the cylinder wall and the piston and the air goes down and you lose compression. Other possibility is if the valves don't close properly. If the valves don't close properly, you have a leak of air on the seat of the valve. This is other common problem. Or other common problem is if the head is broken, if the head is cracked, like the head that you have on the screen right now. When the temperature of the head increase, that crack increase, and probably the coolant enter in the combustion chamber, and you have white smoke. We are going to talk later about that situation. The head is critical. The head is a vital element in the construction of the engine, and the condition of the head is important in order to determine millions of different problems on the engine. We are going to talk later about the diagnosis and the procedure to do diagnosis. But this is the first chapter that we are going to start to talk about the head and problems related with the head, the valves, the head gasket, the piston rings, problems of compression. You remember in the previous episode we calculate the compression ratio, and we calculate the piston displacement, and we calculate the engine displacement. All of those calculations are ideal calculations. What is the meaning of that? Those calculations, those numbers are in ideal conditions. In ideal condition is if you don't have leaks, if the piston rings are in perfect conditions, if the head gasket is perfect, if the valves close and open properly and seal the combustion chamber appropriately. If everything is in good condition, the compression is the maximum compression. The compression ratio is the maximum, and the piston displacement is according with the calculated piston displacement. All right. The life of the diesel engines depend of the compression of the engine. Pay attention. The life of a diesel engine depend of the compression of the engine. Why? Yes, remember, if the compression is not good, when the piston is going up with the valves closed, the piston compress the air appropriated? No. If the piston not compress the air appropriated, when the piston reach the top dead center, probably the temperature and the pressure is not the appropriate pressure and temperature in order to ignite, in order to produce the explosion. When the piston is going up and all the elements additionals are in good condition, the compression is perfect, and when the piston reach the top the center, probably the temperature and the pressure is the appropriate pressure and temperature in order to ignite when the fuel enter in that preheated combustion chamber. The compression in a diesel engines is critical. What happened in a gasoline engine? A gasoline engine with low compression works? Yes, because the explosion is produced for a spark, not for compression of the mixture. In a gasoline engine, if the compression is poor compression, low compression, no problem, because the explosion is produced for the spark, not for the compression of the air like in a diesel engine. What happens if in a diesel engine I have low compression? When the piston reaches the top the center, the compressed air is not at the appropriate pressure and temperature, and when the fuel, atomized fuel, enter because the injector open, probably that fuel now produce ignition, and the fuel goes out through the exhaust pipe, pure fuel. For that reason, in a typical marine diesel engine, if you check outside of the boat and you see a layer of fuel over the water, is because you have low compression in one or two or more cylinders, and the fuel is going out pure fuel. The fuel never ignite in the combustion chamber. This is probably because you have low compression. And there are different possibilities for low compression. One possibility is that the rings are wear or broken, or all the gap ends of the rings are aligned. This is other possibility. Other possibility is that the head gasket is broken. Other possibility is that the valves don't close properly for different mechanical problems. Or other possibility is that the head be cracked. Those are the most common possibilities for low compression in a cylinder, and I am going to explain the procedure to identify if the problems are the rings, or if the problems are the valves, or if the problem is the head gasket. We are going to do that procedure in other video, is how to do the compression test. It's a video clip that you can check in my webpage. Okay, my friends. Yes, the head is one of the most important part of the engine, and in this chapter we are going to talk about the head, and I am going to give to you too much tips about the head. In this particular picture, let me explain quickly that picture. I have the piston. This is the piston, and the piston is connected with the connecting rod and is connected with the crankshaft. This is the crankshaft, and the crankshaft have the gear, the red gear, and is engaged with the gear of the camshaft, the green, And this is the lobes of the camshaft. The lobes of the camshaft are in permanent contact with the lifter. The lifters are hydraulic or mechanical lifter. We are going to talk later about that. And those pipes, those long pipes, are the push rods. The push rods are hollow elements that allow that the oil pass through the pipe internally. On top you have the rocker arms, and the rocker arms in the other end touch the valve. When the loads of the camshaft lift the lifters, this rocker arm goes down and open the valve. Okay, remember the valve, they have a spring here in order, and a retainer. Right now I am going to explain in this video the procedure to remove the spring and the retainer in order to keep the valve closed. Alright, when the valve is compressed here, because the rocker arm press the valve open. This is the procedure to open and close the valves. It's basically with the rocker arm, the push rods, the lifters in permanent contact with the lobes of the camshaft. If you check the gear, the red one is engaged with the gear, the green one of the camshaft, and is engaged also with other gear, the gear of the fuel injection pump. The gear of the fuel injection pump, the fuel injection pump in this particular case is a mechanical fuel injection pump, is engaged directly with the gear of the crank and the gear of the cam, and those gears should be aligned, those marks on the gears, in order to keep the engine on time. Alright, the fuel injection pump, the output of the fuel injection pump enter into the injector, and the injector spray the fuel in the moment that the piston just before, a little before the piston reach the top, the center. I'm going to explain why it's before and not after, but in all the engines is before. Some degrees before. There are some recommendations according with the amount of degrees before the piston reach the top, the center. Yeah, this is the typical diesel engine. We are going to use this picture later. I have another picture similar to this one. This is basically the same. This is the crankshaft, the camshaft, the fuel injection pump. We have the camshaft, the lifter, the push rod. This is the rocker arm. The rocker arm push the valve and open the valve. And this is the piston. The piston move up and down. That's the injector. All the heads, you remember in the previous video that I explained before, all the heads in one side are connected with the intake manifold, and in the other side are connected with the exhaust manifold. The exhaust manifold is connected with the exhaust pipe, no? And the exhaust pipe normally is connected with the turbo. If the engine is turbocharged, if the engine is turbo or supercharged, you say that the engine is supercharged. If the engine don't use turbo, the engine suction the air from the atmospheric pressure, you say that this engine is naturally aspirated. In other words, the carbureted engines are naturally aspirated. And the other engines, turbo or super, they are supercharged engines, because they have the atmospheric pressure plus other additional extra pressure introduced for the turbo. What is the name of that extra pressure? Is the boost pressure. We are going to talk later about the boost pressure in diesel engines. Alright, this is another picture, and we are going to continue right now with the theory related with the heads and the different type of heads, and we are going to share a couple of videos of a job that I did in an MTU V12. Okay, the cylinder head is basically the head, and is located above, on top of the cylinder block, and close the top of the cylinder, creating the combustion chamber. The combustion chamber is the space in between the head and the piston when the piston is reaching the top, the center. That small volume is the volume of the combustion chamber. You remember in the previous video when we did the calculations about the piston displacement, engine displacement, compression ratio, we use that volume, the volume of the combustion chamber. And now we are going to check the different type of heads used in marine application. In marine application, we found that the most common head is the flat head, or we are going to use overhead valves, or we are going to use overhead with the camshaft on the head. Those are the most common heads, and let me explain all of them in details. The majority of the diesel engines, the head is completely flat. The head is completely flat. Oh, what happened? Where is located the combustion chamber? That small compartment. Where is located the combustion chamber? In diesel engines, that pocket for the combustion chamber is not on the head. That pocket is on the piston. For that reason, the typical piston for a diesel engine is like the piston that you have on the screen right now. That piston have a pocket, and that pocket have two functions. That pocket create the combustion chamber. That's the first step, and the second one concentrate the forces in the center in order to transmit the force directly into the connecting rod. Let me make a drawing about that situation. In a typical diesel engine, the head is flat, and you have a intake valve here, exhaust valve here, and on the block you have the piston, and the piston have this pocket. The piston have this pocket, and this is the connecting rod, and the connecting rod is connected here with the crankshaft. All right. The injector normally is located here in the middle, in between both valves. All right, and when the piston is going up and the piston reaches the top of the center, just before of that, the injector spray the fuel and produce the explosion. In this pocket, the explosion is concentrated in this pocket and transmit the final force directly into the connecting rod and improve the performance of the piston and the connecting rod. And the force transmit on the connecting rod is maximum. This pocket have two functions. One function, the first one is concentrate the force, concentrate forces. Okay, and the second function of this pocket is avoid the excessive noise, the excessive knocking produced for the diesel engines during the explosion. The second function is delay the knocking. That characteristic noise of the diesel engines is reduced a little with those pockets on the piston. And other function is dissipate heat, but the most important functions are concentrate the forces and delay the knocking noise, that excessive noise produced for the diesel engines during the operation. All right, the majority of the noise is produced over there and on the fuel injection pump. In the chapter dedicated to the fuel injection pump, I have a great example where that sound is produced, and I am going to explain how the new engines avoid that excessive noise. All right, this is the typical shape of the piston for diesel engines, and in other words, the pocket for the combustion chamber in a typical diesel engine is created on the head of the piston, not on the head valves. Yeah, this is I think so. It's an ABYC question, and it's a common question in the difficult diesel certifications. All right, and this is the most common head, the first one, the flat head. In the example that you see in this moment on the screen, I am removing the head on a V12 Detroit diesel engine. That engine is an MTU engine. That engine, the heads are individual. In that engine, you have one head per cylinder, and it's easy to repair the engine because you remove an individual head and you can repair that cylinder in particular. If you see that head, the head is completely flat. It's a flat head, and in that particular example, we are going to replace the intake valves because a recall of the manufacturer indicate that those engines originally from the manufacturer, they have a problem with the intake valves. The problem in that particular engine was bad quality of the intake valves. When the intake valves are working in contact with the oil and the fuel, the metal is eroded, is affected, is corroded, and destroy the liners and destroy the head of the piston. For that reason, MTU, Detroit Diesel, recall the majority of the boats with those new engines in order to replace the intake valves. And we are going to do that process in different sections of this video. Okay, the most common head is the flat head. And there are different types of flat heads. Right now we are going to check the different types. If the camshaft is on the head or if the camshaft is on the block. Okay, the second head is the overhead valve. The overhead valve, this is a typical V8 engine. If you check, this is a V engine and two heads, one head here, the other head over there, and the crankshaft is engaged with the camshaft and is engaged with the fuel injection pump gear. The red one, the green one is the crankshaft, and the blue one is the camshaft. The camshaft move the lifter. The lifter are connected with the push rods, and the push rods are connected with the rocker arms, and the rocker arms open or close the valves. The rocker arms open or close the valves. If you check this valve is connected with the intake manifold, and the other valves behind of these valves are the exhaust valves connected with the exhaust manifold. This is a typical V8 engine, and this is the typical configuration of the head. The head have the rocker arms, the valves on the head. However, the camshaft is located in the block of the engine. All right, this is the second type of head. The name is overhead valve, and the other one is the overhead valves with the camshaft on the head. I have example of those heads. This is an example of that head. This is an overhead valve with the camshafts on the head. The camshaft on the head. The camshaft is in direct contact with the lifter. This is the lifter, and the lifter compress directly the valves and open and close the valves. You have one camshaft for intake and other camshaft for exhaust. Okay, the intake camshaft open the intake valves, and here is located the intake manifold. This is the intake manifold, and here in those ports are connected the exhaust manifold. The exhaust manifold, those are exhaust valves, and those are intake valves. It's two camshafts, one camshaft dedicated for intake valves, and the second camshaft dedicated for exhaust valve. This is very common. The majority of the manufacturers have designed like this with the camshaft on the head. What is more efficient? All of them are efficient. In my opinion, I never found a difference between one or the other one. This is the process in order to remove the intake valves. In this particular example, we are cleaning the heads. We remove the heads from the block, and right now we have the heads separated, and we are cleaning the heads. The first step is remove the carbon deposits on the heads. This is a lot of carbon deposits on the heads, and we are going to remove the carbon deposits, and with a brake cleaner we are going to clean the heads. After that, we are going to turn the heads with the face facing down, and we are going to prepare the tool in order to remove the springs in order to compress the spring and separate the springs, and after that remove the valves in order to replace the valves. Okay, before we do that project, I am going to explain the components, the typical components of a head valve. The head valve is composed, the metallic part of the head is normally in steel or aluminum, depending of the manufacturer. This is this one, the number one is the head. The number two is the valve cover. Is not in this picture, but is the element that covers the valves to protect the oil and protect the intrusion of humidity and dirt. The number three, in this particular case, this is a head with 4 valves, 2 valves for intake and 2 valves for exhaust. Okay. The two valves for intake are connected together with this bridge. This is the bridge, and the bridge is compressed for the rocker arm. The number 8 is the rocker arm. The rocker arm compresses the bridge, and the bridge goes down and opens both valves at the same time. This is when you have a double intake and double output exhaust valves. Those valves are operated for a bridge, and this is the bridge valve number 3. The number 4 is the spring. The spring, what is the function of the spring? Keep the valves closed. Keep the valve closed. And the valves are moving through the valve guide, like the valve guide that you have on the screen right now. The valves are moving through the valve guide. Normally, the tolerance in between the valve and the valve guide should be inspected each time that you disassemble the head. We are going to check the diameter of the body of the valve, and we are going to check the diameter of the valve guide. And if the diameter is not according with the tolerance recommended by the manufacturer, in other words, if in between the shaft and the valve guide there are too much play, it's necessary to replace the valve guide and replace the valves for a new ones. Alright, in order to avoid that oil enter in the combustion chamber, the most important element is verify that the tolerance in between the valve and the valve guide be according with the manufacturer specification. And additionally, on top of the valve guide is located the valve seal. The valve seal is an spring compressed seal located in the body of the valve and enter in the valve guide according with the picture that you have right now. In this moment in the video, we are removing the valve guide seals, because we are going to replace valves and valve guide seals. Those valve guide seals are very important in order to avoid that a small amount of oil enter in the combustion chamber during the normal operation of the engine. What is the symptom when those valve guides are in bad conditions? Is when you have blue smoke when the engine is running. Blue smoke when the engine is running is probably because you have too much play in between the valve and the valve guide, wear on those materials, and also because that seal is damaged. The solution in that case is not only replace the seal. The solution is remove the head, repair the head, replace valves, replace valve guides, and replace the seal for a new one. This is the procedure to avoid that excessive consumption of oil when the engine is running. Alright, and other important element that we have in this picture is the number 6, is the valve seat. This is the slide that you have on the screen right now. The material used to fabricate those valve seals is Stellite. Stellite is a special steel, hard steel with excessive amount of chromium and vanadium. This is This is normally the same material used in the fabrication on the valve guide. Is Estelite. Normally when you send the head to the machine shop in order to repair the head, they replace the seat of the valves, and in order to be 100% sure that you don't have leaks.